Hello friends and welcome to another video lesson from DBOS Talks. If you haven't subscribed yet, please subscribe button and click the bell. I'll be uploading 1 to 2 videos every week. In this video presentation, I will be talking about logical operators. There are a couple of them, but we will also focus on the main ones, which will really get you up to speed. So these are and, or, in, and like logical operators. But before that, let's talk about something, I would say, something we might have heard in our mathematics days back in school. So let's talk about Boolean. If you remember, if you have watched my previous video, I talked about the main data types, namely number or numeric, varchar2 or character, and then date. Now let's add this other one, Boolean data type. Although in reality, when you use SQL, you will seldom come across a variable code which has a Boolean data type. And seldom will you encounter a column in a table with a Boolean data type. But the reason why we're talking about this is that we're talking about logical operators. And actually, in the process of using one of these or any of these, actually behind the scenes, it is processing. The SQL is making decisions based on Boolean. Boolean has two possible values, true or false. Only these two, cannot be blank. Imagine a power switch. You have a light switch. It can only go two ways. It's either it's on or it's off. There is no or. There is no middle ground. When you have a light switch and you have a light bulb, it's either it's on or it's off. Same thing here. It's either true or false. That's Boolean. Okay, so now that we've understood what Boolean means, then we can continue. I have here a couple of examples that will hopefully deliver the message on, to make it clear what is Boolean. Okay, let's look at the first one. 6 is less than 2. Now let's ask ourselves, is 6 really less than 2? Actually, it's not. 6 is a bigger number, right? So this will evaluate to false. Now let's move to the next one, which is quite easy. It almost looks weird. 1 is equal to 1, or 1 equals 1. Is it true? Yes, of course it is. True. So this is how Boolean works. It is asking questions. And it is most likely guided by what is known as ALU, arithmetic logic unit. Here we have 3 is less than 1. Now you ask yourself again, is 3 really less than 1? Actually, no, it's bigger than 1, it's greater than 1. So this is false. Now let's look at the fourth one. It looks a bit different because it's an equation, all right, because it's an equal sign in the middle. But on one side, there's a constant, there's a number. On the other side of the equation, there's an expression, 10 minus 6, enclosed in parentheses. Now let's evaluate this. 10 minus 6, you will ask yourself, is 4 equal to 10 minus 6? To answer that, then you have to process this. 10 minus 6 is actually 4. So 4 equals 4. That means this is true. So although these are quite simple examples, but the objective really is to have us understand how Boolean works, how the SQL engine or the database itself processes, makes decisions based on the Boolean principle. Let's start with the now all too familiar querying everything. Let's query all. Select first name, last name, country, city from customer, order by country. So we are querying all the records from these 4 columns, 1, 2, 3, 4, of this table, sorted by country. Okay, everything, nowhere condition. There's an order by clause, it's ordered by country. Here it is. Just one thing about order by, the order by clause, which is something you've already seen in a previous video, works in this manner. It will sort by convention, by default, it will sort using this column in ascending order. Ascending, going up, meaning alphabetically arranged, meaning A, B, C, D, E, F, G, etc. But it includes the numbers, not just the 26 letters of the alphabet. So one word that comes to mind when I think of this is ASCII. In the corporate world, you might have heard of this term, and they would often refer to ASCII. They would be referring to a text file, an ASCII file, as compared to a binary file. But the ASCII is actually an acronym. It's an acronym because, as we know, the computer world in our modern age began in the United States. So ASCII is actually an acronym for American Standard Code for Information Interchange. And what it is, although it is a list of codes which assigned number codes to all the characters, not just the alphabet, but all the characters in the keyboard, maybe including those that you don't see in the keyboard. So that ASCII ordering is used when you see this order by clause. Okay, so again, when it order bys, it is by default sequencing, sorting the values according to this column in ascending order. Ascending meaning alphabetical. Okay, let's move on. Question here. Why does this select statement return nothing? It will return nothing. In a moment, you will see. Okay, so you might say, oh, some error maybe, but no, there's no syntax error here. The syntax or the format of the select statement is perfectly correct. Select columns, comma separated from table name, where column name equals a literal value, and there's a terminator. And in fact, the table itself is not empty. Customer table is not empty. I'll show you. It's not empty. And on top of that, we see data for Brazil over here. So why doesn't this work? Okay, I'll show you another one. I have a second SQL statement here, which is very similar to the one above it. If you will look closely, you will see there's only just one tiny bit of difference between the two. So I will execute the second one, and you will see it works. It gives me the data that I want, that I need. And if you read the select statement, it looks exactly the same. Select first name, last name, country, city from customer, where country equals Brazil. But there's a small difference, and that difference matters a lot in the world of, in the data, which when you deal with data, with the data type of character, notice that the Brazil presented in front of us as an uppercase B. Here it is uppercase, here it is lowercase. It's important that you see this difference, the effect of that mistake, small mistake, because it can be disaster for a newbie, for a newcomer, for somebody who is still not yet so familiar. These are the common mistakes as we begin to learn SQL. Okay, so it's because, again, character data type is case sensitive. That is why it's enclosed in single quotes. It's supposed to be exactly like that. So here in the actual data in the table, Brazil has a capital B. So naturally, if you use a small lowercase b in your work condition, you will get nothing. But if you use the one with the uppercase, then you will get something. Okay. So I hope it is clear here in this example that when we deal with data, which is a character data type, we must be careful with and be aware of case sensitivity. Okay. So logical operators, we're talking and learning about logical operators. And these are just my words. Logical operators are used to test if a condition results to true or false. It's like a tester. Now let's use AND. AND is a logical operator. And we're familiar with the word because it's something we encounter a lot in the English language. Exactly because SQL was designed to be English-like. Now, in SQL, true and evaluates to true if the conditions separated by and are both true. Look at this select statement. Select first name, last name, city, country, state, from, customer, where country equals Brazil and state equals SP. Okay, let's execute this and you will see the effect. So here we are querying data from customer table where country equals Brazil and state equals SP. Again, remember that when you use the AND operator, just as when you use it in an English sentence, it works the same actually. What it means is that the conditions on the left and the right of the AND should both be satisfied. If only one is satisfied and this is not, then the data, the underlying data should not be returned, should not be displayed. It should be that both this and this condition will be or should be met. And in fact, it is here. See, Brazil, country is Brazil, yes. State is equal to SP, correct. Okay, that's AND. Now let's use OR. Or just like in the English language, it's used the same actually. So, or evaluates to true if at least one of the conditions separated by OR is true. So let's read the select statement here. Select first name, last name, city, country from customer, where country equals Brazil or city equals Oslo, meaning if either of these conditions, if one or two of them are met, then that's good enough to return the value to show the data for that. So if I will execute this, okay, let's look at the data. Where country equals Brazil, here you go. I see 1, 2, 3, 5 records B that meet this condition, and or city equals Oslo. Where's that? This. Okay. So because of the OR condition, it combines the data that satisfies this condition and the data satisfies this condition into this. Okay. But we have a better way of displaying this. Get a better display using order by. You can see here, if you're doing data analysis or some sort of investigation, then using order by will help you to have a better look at this data. easier to read. So you will do this. Notice that the select statement is very similar to the one above it. The only difference is I added order by country. The first two lines are exactly the same. So again, the condition, the operator being used is the or. So we're saying where country equals Brazil. Yeah, see here. Or the city is Oslo here. But to improve a little bit on the select statement here, I use the order by country for better readability. So you have the Brazil here and then the Norway. You can see the chunk of data which pertains to Brazil and then the solitary one which pertains to Norway because we use the order by country. Okay. Again, remember that by default, the behavior of order by clause is that it sorts the column values, in this case country, in ascending order, ascending, going up, or in layman's term, we say alphabetically arranged. In SQL, it's ascending, but it's by default. That's the default behavior. Okay, having said that, now let's look at another usage of order by. This time in descending. Remember, I told you that the default behavior of the order by clause is to sort the column values in ascending order. Ascending meaning going up alphabetically, A, B, C, D, E, F, G, etc. But here, I'll show you there's another way of using the order by clause, and that is by doing the opposite, which is descending. In ascending, you don't need to mention A as C. It is understood by default that SQL will display it, will sort it in ascending order. But if you want to do the reverse, then you must mention the keyword desk, DESC, which is short for descending. Let's see how it works. So it's the same select statement as the one above it, above this. And the only difference is that order by country, I added desk for descending. So you can see under the country column, the values of country are sorted in reverse alphabetical order because descending. So instead of A, B, C, D, E, then there is Z, Y, X, W, V, U, T, S, R, Q. That way of sorting. That's why here N comes first, Norway, and then the B follows, descending. So we're talking about logical operators for those who have just joined. And this here we covered and, or, and then now we're touching a little bit on order by. This is not logical operator, but as we use logical operators, we come across the usage of the order by, and it really helps in giving readability to the result set, to the data being returned. So we will move on with the other logical operator called in. When do we use in? In is actually when we use in SQL, we are mentioning a list of values. Okay, I will illustrate it better by first showing you the use of or, and then we will later on substitute it with the use of in. So let's look at this example usage of or, the or operator, which we have seen in the previous examples. Select first name, last name, city, country from customer, where country equals Brazil, or country equals Germany, or country equals Austria, order by country. It's quite long, but actually it's not that complicated. We're just saying the country can be either one or more of these three values. It can be a Brazil, it can be Austria, it can be Germany. And then finally, order by country. Remember, ascending order by default. Ascending meaning alphabetically arranged. So if I will execute this one, it presents me this data set wherein the countries represented are Brazil, either Brazil, Germany, or Austria, but sorted by country alphabetically, ascending, which is the default. This is using the OR operator. It looks good and it looks useful and it works nice, but the problem is this. What if you're presented with maybe 10 values for country? Then you will say, for a country it costs this, or country costs that, or country costs this one, or country costs this. You will be mentioning the OR operator for every extra country you will add to the list of possible values, which is not a good idea because it's tiring to be typing that. It's not code. It's very code intensive. It's time consuming, and it can also be an eyesore. And it's also not so readable actually when we talk about code maintenance somewhere down the line. So what is a better way of doing this? Then here is one usage of the in operator, in. So we will be rewriting the above SQL using in instead of multiple ORs. Again, we use the in when we present a list of values as a where condition or in a where clause. So let's look at this one. Select first name, last name, country, city from customer, where country in Brazil, Germany, Austria, order by country. Now let's compare that with the one above. You'll notice it's actually the same as for the first few, for the first line at least, it's the same. And then instead of using multiple ors and repeating myself, where country is this, or country is that, or country is this, what I did was I used the in operator, where country in, and then parentheses, and then the list of values inside it, comma separated, and each value enclosed in single quotes because they are character. They are Parker2. They are literal values. So if we execute this, it will give you the same result. Maybe some minor hiccup in terms of sorting it. Let me just see. City, country. Okay. It's this one. Okay, no, it's the same. So here, instead of using multiple ors, you just used in one time. And it gives you the same exact result. It is wiser to use in as compared to multiple ors. Again, you use in when using a list of values. In this case, a list of character values. We know they're character because they're enclosed in single quotes. Okay, they're comma separated. Next, we'll again use in, but this time for a list of number values, values with number data type. Okay. Select support rep ID, first name, last name, country, city, for customer, where support rep ID in 345. Again, we use in when we would like to introduce a list of values as a where condition. In this example, you can see the difference, the stark contrast. They're both using in the where clause, where in, but because here my values are character, I'm enclosing each one in single quotes. In the second example, because my values are number, they are not in single quotes. 3, 4, 5. I'll execute this. Now let's check the data. Let's check at the column called support rep ID, which is here. By right, what we should be seeing are those with either of these values, 3, 4, 5. And it looks correct. 3, 4, 5. Now, it doesn't necessarily mean that this result set should have all 3, 4, 5 in here. It may have only 3, it may only have 5, depending on the available data. This is just my work condition. In a real scenario, this may even return nothing, and it doesn't mean that there's something wrong with my SQL. It may mean that there really is no value that meets this work condition. So sometimes you can get nothing here, or you may get those maybe with 4 only, or 3 and 5, or 3 and 4, or 4 and 5. That's the reality. Okay. So we've seen the usage of in, which is used when we are have a list of values that we wanted to include in the work clause. And here, in the first example, it's in using a list of character values. In the second example, in using a list of number values. Okay. Now let's go to like. Like is also a logical operator, and we use it in tandem with a wildcard character, not the asterisk. In SQL, we only use the asterisk in the select asterisk, and it means all columns. But the wildcard character in SQL really is not the asterisk, but the percentage. And it is used for doing some kind of pattern search. In this example, we're saying that select these columns from this table where country has this pattern with the use of the operator called like. But if we look at this like, we see quote, capital C, percentage, close quote, close parenthesis. What it means is that I'm looking for data wherein the country value begins with a capital C and may or may not be followed by anything. But my number one requirement is that the country value must begin with the letter C. That's all I want. It begins with a capital C. It may even be just C. If there's such a country like that, then it's okay. Okay, so let's execute this and you will see. Under country column, you can see the values. Canada begins with a C, which means the C must be at the beginning. I don't mean a C in the middle, somewhere in the third, fourth, or the end. I need those wherein there's really a C at the beginning, a capital C. So Canada, you have Chile, you have Czech Republic. These 3 unique values satisfy the condition where country like this. Remember again, in SQL, the percentage works as the wildcard character, and it is used in tandem with the like operator, which is a logical operator. Okay, the percentage is used for pattern searching. In this case, where you're looking for data wherein the country has a value that starts with a capital C. Now let's look at another example of the usage of like. It looks almost the same as the one above it, but the main difference I'm showing you here is you look closely at the wildcard character, the percentage. Here I am using 1, here I am using 2. Select first name, last name, country from customer, where last name like percentage, small e, percentage. What I mean by this is that I'm looking for data wherein the last name contains the lowercase e but that lowercase e is not at the beginning, and neither is it at the end. I want it to be somewhere in between. It doesn't have to be exactly at the middle of the word or of the string of characters, but I don't want it to be at the beginning. I don't want it to be at the end. It must be somewhere in neither in those two positions. So let's execute this and you will see. Remember, we're looking at the values for last name. So when you go at last name column, now let's look out for the letter E, lowercase. And you can see it here, Gutierrez, Gruber. See, the letter E doesn't necessarily need to be in the middle, but as long as it is neither at the beginning nor at the end. It's okay if you have something like this. Elephant. There's an E at the beginning, all right, but this is what I'm after. So this is good enough. But what I mean is, if it's like this, then I will not take that. Because my criteria is that the E should be somewhere neither at the beginning, at the end, or at the end, okay? Okay. So in this video, we've learned about logical operators. We have seen examples of and, or, in, and like. We've come to know what they are used for, how they work, how they differ from each other, how they help. Example, we've seen in an example that the in operator, in one of its usages, is used to improve on what or is doing. We also learned at the very beginning that we've learned about Boolean data type, which has two possible values, true or false, and no other value than that. Okay, I hope you've enjoyed the video and learned all the nuggets from this session. If you haven't done yet, please subscribe, hit the subscribe button. Thank you for watching, and see you again soon.